So today we're going to be looking at properties of logarithms again. So here's just a reminder of what we learned in the previous lesson in the day 3 properties of logarithms lesson. The product property, so when you multiply, when the numbers afterwards are two numbers multiplied together, you can expand them and change it into addition. If the numbers are divided in the quotient property, it tells us that we can subtract. We can expand and change it into a subtraction problem. And then if there's a power like this, we can take that little power and move it out front, and it ends up as n log base b of u. So that's just a reminder of what you looked at yesterday. We're going to use those properties in order to find what the approximate values of these. So right now you can't type this into your calculator because in your calculator there is a log function, but it always has to have a base of 10. Here we have a base of 9. So it tells us that the log base 9 of 5 is about equal to 0.732 and the log base 9 of 11 is about equal to 1.091. So they are about equal to those. So the first thing that we want to do in these is expand the problems. So the first one is division. So that means I can change it into subtraction. So it's the log base 9 of 5 minus the log base 9 of 11. Now you're told that the log base 9 of 5 is 0.732. So I can substitute that in to the expression. So it'll be 0.732. And then you're also told that the log base 9 of 11 is 1.091. So then I can find what the actual value of the log base 9 of 5 over 11 is by just subtracting those two numbers. So the log base 9 of 5 over 11 is going to be about equal to negative 0.359. In part B, we have log base 9 of 55. Well, 55, you can't split that up just by looking at it. It's not going to be the log base 9 of 5 minus the log base 9 of 5. But we know that 55 is 5 times 11. So I'm going to change that 55 into a multiplication problem. Then, because I changed it into a multiplication problem, I can expand it and change it into an addition problem. Oops. So expand it into an addition problem. Then you know that log base 9 of 5 is 0.732 and log base 9 of 11 is 1.091. So just add those two numbers together and you'll get approximately what the log base 9 of 55 is without having to type, since you can't type that into your calculator. So it's about equal to 1.823. Now part C you can do in two different ways. But we know that 25 is 5 squared. So 25 is 5 squared. So when I expand that, it becomes 2 times log base 9 of 5, because that power comes out front. Now the log base 9 of 5, we said, is equal to 0.732. So this is 2 times 0.732. So 2 times 0.732 is 1.464. Why don't you guys go through and try this example on your own? So pause the video, try this example, unpause it, and you'll see the answers. So here's the answers for those three examples. Make sure you check that you did all three of them correctly. So A, the answer is negative 0.526. B, the answer is 1.892. And C, the answer is 2.418. So now we're going to look at expanding some expressions, and some of them are going to be a little bit more difficult than they were yesterday. So we're going to step it up a notch today. So the first one is still one of those basic level 1 type questions. So because it's division, we know that we can change this into subtraction. So it's log base 2 of x minus log base 2 of 4. Now, since there's no more multiplication and there's no powers, we'll be done with this problem. So this would be your final expansion of that expression. In the next one, we're going to get rid of that multiplication first. We get rid of the multiplication first. So it'll be log of 3 plus log of x squared. So when we're expanding, we're going to get rid of the multiplication in this problem first. Then you want to get rid of that power. You can't ever leave a power when you're expanding. So the power will just come out front, and that's your final step. So you have log of 3 plus 2 times the log of x. So once you have no multiplication, no division, and no powers, you're done expanding the problem. So this would be your final answer. In part C, because that exponent is on both the 2 and the x 2x is in the parentheses, I want to get rid of that first. So I'm going to take that 3 and put it out front. So it's 3 times the log of 2x. Now whatever I have, I need to make sure that that 3 is multiplied by the whole expression. So I expand that 2x, so it's 3 times log of 2 plus log of x. So having those parentheses around is showing that that 3 originally started out as an exponent on both the 2 and the x. So this is one way of doing that problem. There is a different way, but this is just one of the correct ways to do this problem. So now we're going to do some expansion problems that take a little bit more work. And I always like to go through the steps. First, I get rid of division. Then I get rid of multiplication. Then I get rid of powers, or exponents. So if I look at that first problem, I first want to get rid of the division. So I have that division problem there. So when I first expand the division part, it's log base 2 of 7x to the third minus log base 2 of y. So I first got rid of the division. I expanded the division. Next, I'm going to expand the multiplication. I have multiplication left right here, 7 times x to the third. So I want to expand that. So I have log base 2 of 7 plus log base 2 of x to the third minus log base 2 of y. So I expanded the multiplication. Then, after you expand the multiplication, you need to get rid of your exponents. And I still have an x to the third there, so I need to get rid of that exponent of 3. So log base 2 of 7, then that 3 comes out front, so it's 3 log base 2 of x minus log base 2 of y. So that last step is your final answer. Log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y, because I don't have any multiplication, division, or exponents left. So when you look at the next example, if I want to expand that, there's no division, so I'm done. I don't have to do the first step. So then the second step says I need to get rid of the multiplication. So to expand with the multiplication, it's log base 5 of 2 plus log base 5 of x to the 6th. So I expanded the multiplication and got rid of it. Then the last step is to expand the exponent. So the exponent needs to come out front. So it's log base 5 of 2 plus 6 times log base 5 of x. So now since you don't have any exponents, you don't have multiplication, you don't have division, the problem is fully expanded and you are done. Now the last example has a little bit of a trick to it also. We still go through the same steps. We first get rid of division. So it's log base 2, sorry, that's my dog, log base 2 of y minus log base 2 of 3x squared. Then your next step is always to get rid of multiplication. But the multiplication was in the denominator, so we need to make sure that that whole thing is subtracted. So it's going to be minus log base 2 of 3 plus log base 2 of x squared. So I expand the whole denominator. Expand the whole denominator. Then I want to get rid of that exponent, that squared exponent. So it's log base 2 of y minus log base 2 of 3 plus 2 times log base 2 of x. Then, since you have no division, no multiplication, and no exponents left, that is your final answer. So in these examples, we're going to condense the expressions. So we're going to shrink them down so they only have one log in them. So anytime you're condensing an expression, you want there to only be one log left. So the steps are going to go in the exact opposite order. So first, we're going to get rid of any exponents, and here they'll look like coefficients. So we're first going to get rid of those exponents. Then we would be getting rid of multiplication, but here, because we're condensing, we're getting rid of addition. And last, we get rid of subtraction. So those are our three steps. In the first one, we have log of 3 plus log of x. Log of 3 plus log of x, we can change into, there's no exponents, there's nothing in front of the logs. There's addition, so the addition is what we want to get rid of next. And addition is multiplication. So when I condense this, I have the log of 3x. Then, since there's no exponents, there's no more addition, there's no subtraction, I'm done with that problem. Now in this next example, you see something new. It has ln. That's the natural log. What the natural log of x equals, it equals the log with a base of e. So that's something new. We'll be studying it more throughout this unit, but that's something new. The natural log of x equals the log base e of x. And any properties that we know about logs also applies to the natural log. So here, since we have subtraction only, we're going to change that into division. So we have the natural log of y divided by x. And that would be your final answer because we have no exponents, we have no addition, and no more subtraction. In the last example, we first want to get rid of that exponent, which here looks like a coefficient. So we have the log of x squared plus the log of 8. So our first step is to get rid of exponents. Our next step is to get rid of the addition. So the addition we would combine and it would change into multiplication. So we have the log of 8x squared. Then since there's no subtraction, you are done. So just go through those same steps in the reverse order of what we were doing before. Here are 3 examples that are a little bit more steps than what we were just going through. We're still condensing, we're still getting it down so there's only 1 log left, but there's a little bit more condensing that we have to do. Same steps still apply. We first want to get rid of those exponents. So first, this is going to change into log of 6 plus log of 2 squared, because that 2 out front becomes the exponent, minus log of 3. Then we get rid of addition. It's the next step. So it's log of 6 times 2 squared minus log of 3. So remember, addition becomes multiplication. Then our last step is to get rid of subtraction. So it's log of 6 times 2 squared over 3. So the power or the coefficient becomes an exponent, addition becomes multiplication, and subtraction becomes division. Now I have everything simplified. I could just leave it like this. This would be a great answer for you. If you want, you could do 2 squared is 4, so I have 6 times 4 over 3. Then simplify it more. You have 24 over 3. And 24 over 3 is 8. So you could have log of 8. Both of them in the red box are going to be great answers. I would accept either one. In the next example, we actually are going to have 2 exponents. I have 2 coefficients that then become exponents. So it's log base 3 of 7 squared minus log base 3 of x to the 5th. Now there's no there's no addition, so I can't change anything into multiplication. But there is subtraction, so that will become our division. So it's log base 3 of 7 squared over x to the 5th. Now I'm down to only 1 log, and that's what I want for my final answer. Only 1 log in your final answer when you're condensing. In the last example, again, we first are going to get rid of the coefficients. Those are our powers, so we have 2 here. So it's log base 8 of x squared minus log base 8 of 5 minus log base 8 of y to the 3rd. Now I have no addition here, but there is some addition that's disguised here, so you'll see what I mean in a second. It's all subtraction. So it's going to be x squared, and x squared is going to be divided by both of the things here. So log base 8 of x squared divided by 5 and y to the 3rd. So 5 and y to the 3rd are going to be multiplied together in the denominator. That's where that multiplication in disguise came in, because both of those were subtraction. They're going to be multiplied together in the denominator. So then, since I'm down to only 1 log, that is your final answer. And these can get tricky. You just need to make sure you keep going through those steps. Make sure you get rid of the exponents or your coefficients first, then get rid of addition, then get rid of subtraction. And just keep going through those steps, and hopefully you'll get the hang of it. So I had mentioned earlier that you can't just find the log base of 5, log base 5 of 7 in your calculator. There's a special formula that you need to use because in your calculator, the log is always going to have a base of 10. So if it's not a base of 10, then you have to use the change of base formula. And the change of base formula says that the log base c of u equals the log of u over the log of c. Typically, you are going to be using this formula. The other formula, the log base c of u equals the log of u, the natural log of u over the natural log of c, that's just another way of looking at it. You will get the same answer in the end, but typically you'll see it as the first one that I have boxed in red here. So when you're asked to evaluate the expression in the first example, the log base 3 of 7, using the change of base formula, you can't just type in the log base 3 of 7 into your calculator. You have to use the change of base formula. So this will be the log of 7 divided by the log of 3. And make sure if there's parentheses that you close those parentheses. We should have closed parentheses around here. Otherwise, your calculator is going to calculate it incorrectly because it'll calculate it the way you asked it to. So the log base 7 divided by the log of 7 divided by the log of 3 is 1.771. So the log base 3 of 7 equals that. The log base 3 of 7 equals the log of 7 divided by the log of 3, which is equal to 1.771. The same is going to work for example B also. So we have the log base 6 of 15. That equals the log of 15 divided by the log of 6. The log of 15 divided by the log of 6, and remember, you want to make sure that you have closed parentheses around here. That's going to be equal to 1.511. So that's how you find the value if your base is not 10. If your base is 10, you can just plug it right into your calculator. If it's not 10, you have to use the change of base formula to figure out what it is equal to. I just wanted to show you guys, this is the dog that was going crazy while I was writing the lesson. It's my parents' dog. His name is Buddy. I thought you guys would like to see him because he's really cute.